Open source code bases are overwhelming, especially the massive ones like CPython. The best way to build an understanding of it is by making simple changes. In this video, we change the Python language and add a new statement, NUKE. This statement would abruptly kill the runtime. It's the most simple yet significant enough change that we can make in the Python language. The intention of this video is to make you all understand how easy it is to make simple changes to massive code bases and contribute to open source. This is the second video of the series, so I would recommend you to check the other ones as well. Let's jump right into it. Now here what I have is I have set up CPython locally, where if I do /python, it would start the Python shell, it would start the Python runtime from the code, from the source code which I have locally. Right now here when I type in NUKE, so first for example, if I just want to stop the runtime, I can just pass in exit bracket, like I'm invoking the exit function call, which would just stop my Python runtime, and I can do an echo $, which basically returns me 0, which is an exit status code. Now what we are trying to do, this was a graceful shutdown. What we want to do is we want to do NUKE. When we do NUKE, we want to just kill the runtime immediately. This is a simple change that we would make, but we have to go through a lot of files to understand what we are trying to do over here. Right now, when I do NUKE, we have to kill the runtime, and I'll use an exit code 45 because in the year 1945 the atom bomb were dropped. So I'll use an exit status code of 45 over there. Okay, so let's see how we should approach making these changes rather than like directly me saying that hey, these are the changes that you would need to make. Let's understand the thought process behind it. So what are we trying to do? We are trying to add a new statement called NUKE. NUKE does not take any argument, right? So let's find out which other Python statement exists that is just a one-word statement, not a function call, and it does not take any argument. One statement that came to my mind when I was thinking about this is break, because when we are in a for loop and we write break, it breaks out of the for loop, right? So which means that the statement that we would want to implement would be very similar to how break is implemented, right? So what we would do is we would start adding wherever we see break happening, we would just add our code next to it called NUKE, right? Let's see how it goes. First of all, what we have to do is we have to add support for the NUKE word in my Python language. So which means, and obviously every language has a grammar. This language also has a grammar. You can find it in a .gram file in grammar folder. And this is the peg grammar which is written for this language. Even I don't know a thing of it, right? But for us to make simple changes, you don't need to. That's the beauty of it. So long as you are able to narrow down the changes where you need to make good enough, right? So what do we want to do? We want to do where the break is, we would add our statement next to that, right? And while obviously not just bluntly adding it, we would have to go through few lines up and few lines below to understand that, hey, are we even adding it at a good place or not? So let's find where the break is implemented. We could see in line number 123, I could see a break and a continue. And I could also see a pass. Oh yeah, I forgot about pass. Pass is also a statement that we pass having no arguments. Break is there, pass is there, continue is there, return, and then some argument is there, but we'll not go into that. Break, continue, which is exactly what we want. So what we'll do, copy, paste, right? And instead of continue, I'll add NUKE to that, right? And here it is pyast. I don't know what AST is. I don't know what _pyast continue does. I know AST stands for abstract syntax tree. Even if you don't know, that's fine. But you can very clearly see that break has pyast break. Continue has pyast continue. So NUKE would have pyast NUKE, right? So wherever this pyast break is implemented, do a depth first search. Wherever this pyast break is implemented, you go and implement that, right? And then whatever unknown is, you implement that over there. So I look for pyast break everywhere in my code base. Control-Shift-F is your best friend over here. So I look for pyast break. We found this where we make the NUKE changes, number one. Second place where we found is over here. So I'll just do a copy paste. I could see a lot of function definitions written over here. I would just add that pyast NUKE. And do I need to change argument? Every function looks like having the same set of arguments. So I'll keep it as is. Then the next change is in parser.c. This file is where we typically know that, we should know that this file, you could see a pyast break added over here, but this file is a gigantic file. And this is a parser. Typically what happens is in a language, you don't change the parser. The parser is generated like Lex and Yak that you folks might know. That is how a parser is generated for that language. So we define it in the grammar. Using this grammar, this parser file is generated. So we'll not make any changes over here for anything related to break. We don't have to, right? So we'll not touch the parser.c file. We would auto generate it in couple of minutes, right? Okay. Then another place where we could find is python ast.c, where I could see that because we declared the function pyast_nuke. This is where the break is. So this is what the definition of the function is. So now I do a copy paste and I do a pyast of nuke. I go through the function body to see what are they doing. Is there anything specific about break over here? I could see statement, something malloc, something break kind. Oh, break is over here. Let me change it to nuke kind. I don't know what this is doing. Just making those changes because looks like this is how something it would be finding out what kind of statement are we passing over there. I'll just put it after continue just for the cleanliness of it, right? So I added pyast nuke and I added this new variable. Now depth first search. I added this new thing, nuke kind, which is similar to break kind. So let me go through that and search for break, BREAK kind, and a case sensitive search, and I find this 5-6 references. I'll go through all of them and make changes, see if I would require any changes. Here I could see pass kind, break kind, see pass kind, break kind, continue kind. I'll add my own kind, which is nuke kind. And I'll add 26, 27, I'll add 28 to this. First change done. Second is over here. Here we are having a pass kind, break kind, continue kind. But instead of just bluntly adding a nuke kind, let's see what this function does, because you cannot just bluntly add it everywhere because break has a different use case, nuke will have a different use case. You need to understand where you are adding. So we'll just scroll up and see what it is doing. If it looks like really long, we can just skip it, but we can see some calling is done and AST fold statement. We still don't understand the thing what we are trying to do, but it looks like some calls have been made over here. If kind, with kind, and then you are invoking something. That's okay. But here we see that pass didn't do anything, break didn't do anything, continue didn't do anything. So we'll add nuke. It will also not do anything, right? We'll see. We'll trial and test and see what happens. Then the next file is ast.c. Here you find break kind. Here you find continue kind. Let me add a case called nuke kind. But here, what we just changed. We added this RET equal to 1 was first part of this continue kind, but now we added nuke kind after continue kind. Let's see what this is actually doing, because we cannot just, what if this return 1 had some significance? So let's see what this function does. If you look carefully, if you just scroll a couple of lines up, you could see a lot of validations happening. Non-empty sequence, something, import has some validations happening, non-empty sequence and all. So this looks like a function that is taking care of validation for each kind of statement. But if you look carefully, because we are not accepting any argument, neither pass nor break nor continue, because we are not accepting any argument, it's okay to just return 1, which would mean that it's an okay statement. Because here we see return less than 0, unexpected statement and something around that. So this looks like a good change for us, right? Okay. The next thing is this compile.c file, which had this break kind and it is compiler.break. So we'll do copy paste after continue where the break kind is. I'll change it to nuke kind, and in the compile_break, I'll do compiler_nuke, which means now we have to implement this function because it's a function call. This function would be implemented somewhere. Right next to it, we would implement a nuke function. We'll come back to that, right? Then let's come to this next file, Python AST. Here you see pyast.break. This is where we implemented that part. We stumbled upon it again because this is this pyast.break, which contains break kind, and we changed it to pyst.nuke to nuke kind. We added that block, remember? This is where we started and we circled back, right? So this change is taken care of. Now the next change where the break kind exists is this. This is, I don't know what this does, but looks like some generic object that is creating. Copy paste. I change this break kind to nuke kind. And now what we see is some state is equal to break type. Oh, looks like we have to add a new type. We added new kind. I don't know what that is. And you don't really need to know to add a new support to that. Over time, you would build that intuition, or over time you would build that skill set to do it. Even I don't know what that is. So I'll do nuke type. And now the next thing is we have to find references of break type and see where we need to change. But let's first close everything around break kind. So we made this change. We added the nuke kind and then nuke type over here. Now we go to the symbol table and we see, do we need to change anything? Continue kind, do nothing over here. Looks like for pass we are doing nothing. For break kind we are doing nothing. For continue kind we are doing nothing. Nothing to do over here. We'll add that same thing for nuke kind. Nothing to do over here, right? Because we are not doing, because this looks like where we are visiting in the tree and all. Let's just change and see if it works or not, right? Because it's okay to make mistakes. The thing that we added in the past, in the previous file was the nuke type, which was similar to break type. Now let's see the references of break type, right? And make changes there. So I see break type reference over here. I copy paste. And what we want to do is we want to call nuke, and I can see that this file is arranged lexicographically or alphabetically. So I'll go to N and add my statement not equal to no, and I'll add nuke type to it, right? Then I see this another object. This file is done. Now we come to Python AST where I could see pyclear break type. I don't know what this does, but looks like every single type has some entry over here. So I'll add one entry over here. Now you can see how even if I don't need to know what each one of this is doing. I can just make referential changes everywhere and just sort it out for mine, right? So I've added pyclear. Now here I could find another break type where it is doing state arrow break type something, state break type, and then there is continue. I'll copy paste this 2 line and add it after continue like we have done everywhere. I'll add nuke over here, nuke over here, nuke over here, and nuke over here. Even I don't know what I'm doing, but let's try, right? We'll make first all the changes. We'll run and see what happens, right? I made changes over here, break type, nuke type, this change is done. We come over here, we see nuke type, nuke kind, and this is where it all started. We added nuke type. It was already added because this is where we discovered we have to add something called as nuke type. We added that. We added the state. Now this is another change where we see break type. Now for this break type, I could see, I'm not able to understand what this is. So let's go a few lines up and few lines down to see what this is actually doing. So I could see break type starting over here, some instance checking, some checking is instance. Then this is where the function is getting invoked, right? That break, that pyst break, pyst nuke we added, this is where it is getting invoked. So let me just do a blunt copy paste of it. When we see break implemented over here, continue implemented over here, and it's the end of it. So, but before we add it, let's look at the next line. It says error, expected some sort of statement, but got percentage R. I don't know what that is, but this tells us that this is where we have to make an entry, because if we are not adding it, it would not identify the nuke type of it. It might throw an error. So let me add nuke type over here is instance, and we added pyst nuke over here. This is where the pyst nuke that we defined over there is getting invoked over here. Looks like pieces are coming together, right? And then this change is done. The last change we see over here is break is added over here. I'll just go to continue and add my object reference. We added this type. I add my nuke type over here and I change it to nuke, right? We made a bunch of changes, right? One thing that we have to remember, that compiler underscore break that we just saw, we have to add compiler underscore nuke somewhere, right? This was that file where again DFS, we went through that, made all the changes, we came back, we visited or we recalled, hey, this was one change that was remaining. So let me just do this compile, this compiler underscore nuke, right? So, but we don't know where to implement. So we'll take help of compiler underscore break and we figure out two references of it. I could see a function. I'll do just blunt copy paste. I'll put it compiler continue. I'll put it next to it because we have always been putting break continue and then nuke. So I just do compiler underscore nuke. It takes some compiler object and some location object. I have no idea, but that's okay, right? And this should be the function call that is happening. I don't know what all of this does, but what we want to do is we would just want to kill everything, right? We just want to kill it. So what I'll do to kill a C process, what we'd have is we have exit code. We write exit, right? And in exit, we can pass an exit code. So here I'll pass 45, right? So we completed our DFS. We made all the changes for break kind. Sorry, we went through all the changes of break kind, added nuke kind next to that. We went through all the changes of break type, add nuke type next to that. We added the functions wherever we could find a reference of it and we sorted that out, right? Now looks like we have done it all. I'm not sure, but let's try to build it. Now for us to build, we fire make command. But one thing to know is whenever we change any grammar, a grammar's parser is automatically generated. Remember, we made changes over there. We did not change anything in parser.c file and I said it is auto generated. That's how your grammar's parser is generated. So in Python, for us to generate Python grammar, or rather the parser for Python grammar, whenever we make any change in the grammar, what we have to do is we have to run regen -pegen. This I found by doing Google. On Google search, I searched, hey, how to change CPython grammar. And I found that whenever you change anything in .gram file, you have to run this command. When I run this command, this generates the parser for the new statement or the new grammar that I've made changes to, right? So this parser is what it was showing in the result, that this is where you need to change. This parser is now auto generated, so we don't have to change anything there. So if I just open this file, parser.c over here, I should see nuke statements. And see, I'm seeing the nuke statements. This is nuke, token, nuke, and I could see anywhere else. I could see nuke, pyast nuke getting invoked over here. See, this file was, we never made changes over here, right? But parser is picking that up and generating this file for us, right? So we did this. Now we regenerated the grammar, regenerated the parser of our language, and now we will run make. Because we made changes to a lot of core files. So whenever we run make, a good open source project typically has a very sophisticated make rules. So depending on the files that you change, it would only do partial compilation of those files and just link the existing ones. So the files that you didn't change would not be compiled again. Their shared object files are created and only the linking happens at the runtime. Now, because we changed some very foundational files, grammar, everyone uses it. Those AST files, everyone uses it. So the building process will take time, typically 3 to 4 minutes, right? So let's wait for this to complete. Once this completes, we will try to execute and see if our changes work or not. So now the compilation is complete. It took roughly 6 minutes to wrap this up. Now that the compilation is complete, the binary is created. There is no syntax error, nothing, which means all the changes we did, at least it was complete in the sense that our binary got built. Now let's see by running our own interpreter and see if it has the changes or not. I ran, and let me just do an exit to see if existing functionality didn't break. It did not. It worked just fine. Now let me type in nuke, hit. And the program abruptly terminated. What did we write in the exit code? 45. So if I do echo $? I got 45. And this is how you make changes to a massive code base without knowing a thing about it, right? Just basic things here and there. Just figure out how, just try to deduce, apply first principles and figure out what's the most similar thing to this. And then just start making those changes alongside that, right? So when what we did, we knew we had to add a new command called NUKE. We found a similar command called break, or rather having same syntax, and then we started changing everywhere the break existed, right next to it. That's exactly what we did, right? But this gives us a very nice idea on what all things are there. Although we didn't understand what AST does, how it stores stuff, but at least it made us more familiar with this code base. There is some AST file and some tree structure created, and some places there is some kind and some type and this and that. And that's how you evolve in an open source code base as massive as this. Smaller open source code bases are fine. Such massive code bases have a lot of things already abstracted. So this just helps you navigate through that. And yeah, I hope you found it interesting. Hope you found it amusing. This is that one series I'm really pumped about, to go deeper into CPython internals and help you all understand how to navigate through massive code bases and make some changes here and there and understand how things work while helping you understand how to contribute to open source code bases. And yeah, that's it for this one. I'll see you in the next one. Thanks, Eta.